All right, assignment 8.8, partial fun. So we're looking at this problem, and we see integral 9x over x squared minus x minus 2. Logically, we think, okay, well, u is going to equal the bottom, which is x squared minus x minus 2. And that gives me du is equal to 2x minus 1 dx. Now, there's a problem with this. I have to put a minus 1 in here. And I have to figure out how to turn the 9x into a 2x, and that's just not going to work, because if I subtract a 1, I have to add a 1 inside. And adding a 1 inside means I have to then move it all the way out in the integral, right? I can't have, if I had like 9x minus 1 over this, I'm just creating more fun for myself, right? Because there's nothing I can do to this that's going to be any better than what I just did. So there's no way to attach it to the top. If I add a minus 1, I'd have to add a 1 over x squared minus x. Oh, sorry, this should be an x minus 2. Okay, so there's nothing I can do to add a 1, which is what this thing says I have to do. The bottom's bigger in power than the top, so therefore law of division isn't going to work. So if these two things don't work, what I'm left with is something called partial fraction. So hopefully you remember that last year, for most of you, I taught you partial fractions. Partial fractions, if you remember correctly, is a way to write one fraction involving polynomials into two fractions. And it's the realization that the bottom, when you multiply the bottoms across the tops, the bottoms are going to be factors of the bottom, right? So I can look at this and go, oh, that's just x minus 2, x plus 1 would be factors of the bottom. So take again, what I'm doing is I'm looking at the bottom and saying, look, the bottom has to be factors of this side over here, right? So therefore, I just come up with two factors that match the bottom over here on the left-hand side. And then I go, well, I make this an A, and I make this a B. Now I'm going to solve what those must be. Okay, that's the way this works. I'm going to solve what this must be. Okay? All right, so how do I solve what this must be? I go ahead and remind myself that if I multiply my bottoms across the tops, I'm going to end up with 9x over x squared minus x minus 2 is going to be equal to a times x plus 1 plus b over x minus 2 all over x squared minus x minus 2. Now note the bottoms are always going to be the same if I factored correctly. So if I factored correctly, I don't even have to worry about the bottoms because the bottoms are always going to be equal to each other. I'm simply got to worry about the top being equal to each other. Now there's a cute little trick by which I can get the top resolved. It has to work for any x, so I'm going to pick what makes one of these two things go away, because I got three variables, right? I don't really want three variables. It's got to work for all x's, so I can pick any x I want to check. So I'm going to check if x equals negative 1. When I do that, I'm going to get 9 times negative 1 equals a times negative 1 plus 1 is 0, right? And so that goes away. So this is all going to go away, which is why I picked that number. Then b, negative 1 minus 2, right? So I get negative 9 equals negative 3b, and I get b must be equal to negative 3. Nope, yes. Nope, positive 3. Good, sorry, I don't have an eraser anymore. I don't know what's happening with paint right now. Okay, so b must be equal to 3. And I'm going to do the same thing, and I'm going to say if x equals what makes this equal to 0, which is if x equals 2, right? If x equals 2, I get 9 times 2 equals a, 2 plus 1, plus a b, 2 minus 2. That goes away because that's a 0. And I get 18 equals 3a, where a equals 6. Which means 9x over x squared minus x minus 2 is going to be equal to, that's equivalent to 6 over x minus 2 plus 3 over x plus 1. Now, if I wanted to, I could check this answer by foiling it back together again, right? Sorry, by finding a common denominator. Now, you're not going to have to do this. This is what I want, right? This is my goal, because I can take the derivative of that. How do I know that? Well, because the bottom power. So now I'm looking at a situation where this is just multiplied, and so I can write this as u and write it as an ln. Okay, so because these are simple factors I can deal with. And so let me go a little farther and go, if it is true, then 6x plus 6, right, crossing this way, plus 3x minus 6 over, and again, the bottom would be just x squared minus x minus 2, because I'm forming that back together, the factors. And that gives me 9x over x squared minus x minus 2. So these are equivalent. So this whole thing is equivalent to that right there. So now I'm going to rewrite my integral as 6 over x minus 2 plus 3 over x plus 1 dx. Now there's a plus in the middle, so we can do them separately. I'm going to go integral of 6 over x minus 2 dx plus the integral of 3 over x plus 1 dx, right? And so I'm going to say u equal to x minus 2 du, therefore equals 1 dx. 1's easy to make. I'm just going to pull a 6 out in front because I'm lazy. Integral of 1 over u. I'm plugging in the u right away. Is that okay with everybody kind of running out of space here? So this becomes 6 ln absolute value of u plus c, because again, the integral of 1 over u is ln of u, absolute value of u plus c. So I get 6 ln of x minus 2 plus c. And then I got to do with the same thing here. I'm going to say v, because I don't want to use u again, x plus 1 dv equals 1 dx. That's easy enough to make. I pull a 3 out in front. I get 1 over u d 1 over v dv. And then that's going to give me 3 ln absolute value of v plus c. There's a little pluses in the middle here. Plus 3 ln x plus 1. I already got the c built in, so this is my final answer. Okay, so if I do partial fractions, this is a way to get my answer fairly quickly. Okay, now I did a lot of extra work here. Let's do it for realsies. Okay, so go and try number 7, and then I'll do number 7 in just a moment. All right, I'm going to start number 7 in just a moment. So if you don't got number 7 tried, go ahead and hit pause. If you do have number 7 tried, keep listening. Here we go. I take a look at this. First thing I do is I think, well, u must be x squared minus 1. So u equals x squared minus 1. Eventually you start recognizing and probably skip this step. But I get 2x dx. I realize I need an x up here. There's no way to make an x out of thin air without making an x and a 1 over x, and that's just going to make the thing completely ridiculous, so we can't do this. So nope, didn't work. Then we recognize, well, I can factor the bottom, so I'm going to go ahead and do that. So I'm going to rewrite this as, so I'm just going to take out the partial fraction. We go 1 over x squared minus 1 equals a over x plus 1 plus b over x minus 1. And again, I recognize that the bottom's going to always match, so I get 1 equals, if the bottom's going to match, I cross the tops, I get a x minus 1 plus b x plus 1. And then I got to figure out what x's make it equal to 0. I'm going to choose what makes this equal to 0, which is x equals 1. If I do that, I get 1 equals a, 1 minus 1, that's b, 1 plus 1. And I get 1 equals 2b, or b equals a half. Fair enough. And then if x equals negative 1, then I'm going to do 1 equals a, negative 1 minus 1, that's b, negative 1 plus 1. Pausing. Sorry about that. Apparently today we have a snow day. All right, let's keep going here. I got 1 equals negative 2a. Again, this part cancels out. Gone. I got a equals negative 1/2. Now, last year your teacher was all angry about this, but we don't care. We're just going to leave the fractions on top. And so a was negative 1/2 over x plus 1 plus b, which is 1/2 over x minus 1 dx. So I set u equal to x plus 1, so du equals 1 dx. I don't need the negative 1/2 out in front, so I rewrite this as the integral of 1 over u, so the negative 1/2 out in front, du plus 1/2, oh, I did my movie, v equals x minus 1, so dv equals 1 dx, and then I've got this, therefore I get an integral of 1 over u du, and then I get negative 1/2 ln absolute value of u plus 1/2 ln absolute value of, this should be a v, my bad, absolute value of v plus c. And then that gives me negative 1/2 ln, and u was x plus 1 plus 1/2 ln, the v was x minus 1 plus c, and I'm good to go. Now, a warning. See these bottoms? These bottoms are working out nicely because they're x minus 1, so the derivative is 1. And so I'm basically racing through these problems because they're not nasty. If one of these bottoms is 2x minus 1, I'd have to then deal with the fact I'd have to get a 2 in front of the x. You know what I mean? I don't know if you know what I mean because I'm just not even looking at you, but hopefully that works. Okay, so let me see here. Try problem number, let's try 11. Try problem number 11. And I'll get back with you. Actually, try number 9 in between, but then do number 11. And I'll get back to you with 11. As promised, number 11. Starting number 11, I take a look at it and go, okay, it's one of these partial fractions, one that can factor the bottom. If I can factor the bottom, I'm going to go ahead and do that. I factor the bottom so it matches. And I get to this step, and I get 5 minus x equals a times x plus 1 plus b times 2x minus 1. I'm going to say if x could equal negative 1, then I'm going to go 5 times minus negative 1 equals a negative 1 plus 1 plus b times 2x minus 1. And I get 6 equals, oh, I forgot to put a negative 1 in here. So I'm going to 6 equals b times negative, is that negative 5? Ooh, negative, no, it's negative 3. So b equals negative 1/2. Isn't that nice? And then if x equals, to make the second one negative, I need a positive 1/2. So that's going to be a mess. So I get 5 minus 1/2 equals a times negative 1. I messed that up. Sorry, I have no eraser today, apparently. So I'm going to get 1/2 plus 1 plus b 2 1/2 minus 1. Again, this becomes 1, so negative 1 minus that goes away. And then I'm going to get 9/2 equals 3/2 a. I flip and multiply, I get 18/6 equals a, or a equals 3. Again, the reason I'm showing this problem is because now I'm in the integral, and I get 3 over 2x minus 1 plus b over x plus 1 dx, and b was negative 1/2. Okay, so I separate these. Integral of 3 over 2x minus 1 dx plus integral of negative 1/2 x plus 1 dx. I set u equal to 2x minus 1. I get du equals 2 dx. And then I'm going to pull out the 3. I get the integral. In order to make a 2, I have to pull another half out. So I get my 2 dx, 1 over 2x minus 1, plus, and this one's going to work like the other ones were, integral of 1 over x plus 1 dx. And again, that happens because I go v equals x plus 1, dv equals 1 dx. Okay, I got my 1 dx by pulling my negative 1/2 out in front. Then I'm good to go. So this gives me 3/2. This becomes ln of 2x minus 1 absolute value. And then that dv went away, minus 1/2. And then I get ln of absolute value of x plus 1 plus c, and that's my final answer. Kind of rush that a little bit because I'm running out of time. But that's the way that works, okay?